Hello and welcome to a demonstration of Infolytic MetaMiner, high-performance SAP Business Objects Platform Administration. During the course of this demonstration, we will take you through a few key concepts of why Infolytic MetaMiner is the best way to both administer and analyze your SAP XI3 or BI4 landscape. We'll take you through a few of the key concepts around how it benefits you architecturally speaking, then take a tour of the MetaMiner standard reports that provide a number of different analyses on your SAP Business Objects platform, and finally take you for a brief tour of the MetaMiner client, which is a first-to-market innovation that gives you a high-performance visual analysis capability to understand things such as impact analysis, server utilization, alerting of various platform events, BI search and discovery, impact analysis, and more. Infolytic has been working in the SAP Business Objects space for several years, trying to fill the gap where SAP has been unable to allow administrators and architects to easily perform the tasks and jobs of managing the BI platform. MetaMiner, fortunately, helps fill that gap, and as we just discussed, we're going to go through a few of the key areas in which the administrator now has ultimate control over their BI landscape. The MetaMiner architecture is fundamentally multi-tenant, multi-version, but single instance. This allows MetaMiner to use a highly adaptive engine to constantly query in real time all your different environments or your landscape in total. So if you have BI4, production, QA, dev, or pre-prod, all of those environments are managed by a single installation of MetaMiner that then persists all of that data to the MetaMiner database, as well as maintaining live connections to all four environments for advanced analysis and write back. The user experience of the MetaMiner UI is strictly based around optimizing workflows that typically take many mouse clicks or keystrokes to perform through traditional mechanisms such as the CMC and other tooling. So let's take a step back and really understand what SAP has been doing in terms of their platform evolution. As you can see here, the focus has largely been on the user-facing analytics, reporting, discovery, dashboards, and integration with Microsoft Office. This is wonderful, and we're really glad that SAP has been able to allow our end users to do even more, answer more challenging questions around their business with better software. But SAP BI administration is not as fun as what it looks like for our end user population. Having been given a stable of small utilities that work in a piecemeal fashion, some performing function A, others performing function B, it's been more than just a challenge to do something as simple as bringing a new object into the system, versioning it, then putting it up on a backup schedule, and then finally performing impact analysis to see what other objects that object may impact or already impacts in the new system. So traditionally speaking, we've had questions that we've always been wanting to ask of our platform. What objects use a particular universe? Or knowing when the APS might be reaching its capacity in terms of servicing incoming requests, or promotion management, or even knowing when the Tomcat application server is up or not. And the list goes on. So the question becomes, why do we have to use 9 or 8, 10 different tools just to answer seemingly obvious questions? Well, let's take another step back and see historically the evolution of the BI platform. So in 1989, Seagate Information, aka Crystal Decisions, developed what they called the CMS. Now, as you know, the CMS, or the Central Management Server, is the backbone of the business object system, and this backbone historically was only meant to provide pointers and the binary content on a file system for Crystal reports. Now, as time evolved, fast forwarding to 2015, the CMS evolved into, okay, well, I guess the fact is it didn't really evolve into anything. However, business objects purchased Crystal Decisions, SAP purchased business objects, and now all of a sudden you've exploded from just a Crystal Report portfolio of client-facing analytic tools or content managed by this CMS repository to more than 24 object types: PowerPoints, Web Intelligence, Lumira, Exploration Views, Full Client, Desktop Intelligence, etc., etc. So now, this 30-plus-year-old technology has been forced or shoehorned all the way up to present time to fulfill enterprise BI needs that go far beyond what the use cases were 30 years ago. And as you know, trying to evolve a system over time is very difficult to do, especially when the number of dependencies create significant backwards incompatibilities when we do want to make a revolutionary change in an existing architecture. So Infoletic MetaMiner is a first-to-market technology that encompasses broad spectrum needs of BI administration and analysis. And as I'd mentioned before, the real-time engine within MetaMiner allows very effective and efficient generation of metadata, statistics, and security of the landscape, which is really what is managed within the CMS. So while the CMS has been evolving very slowly, MetaMiner is a new current state best-of-breed technology that brings the technology of the CMS backbone truly to 2015. Taking a little look at the MetaMiner architecture, we can see precisely just how the engine works. So over on the top left, you see the MetaMiner server. The MetaMiner server maintains a few different connections to my environment. The one type of connection that it maintains is directly to the audit database, and that connection retrieves through pure JDBC information around all of the utilization and system events that take place for each environment, BI4 or XI3. A second type of connection that's maintained to the environments is an enterprise session, and the enterprise session allows MetaMiner to understand the metadata of the system, such as security, and retrieving things like UNV and UNX files into the MetaMiner environment to parse, extract, and catalog all of that metadata into the MetaMiner database, or MMDB. We also maintain connections to the environment in real time that allows administrators to perform a great deal of very high yield, high value write back actions to the system in bulk. Okay? And being able to do that, of course, makes MetaMiner a fully rounded administration and analysis tool, as we've been mentioning. So at the end of the day, what you're seeing here is the MetaMiner user interface that now allows us to take all that platform metadata and visualize it, and allows to quickly slice and dice and navigate through it as if it were something as trivial as a Windows Explorer looking into all the different resources or network shares of my organization. And this is the type of fundamental paradigm shift in BI platform analysis that Infolytic hopes to achieve and share with customers and prospects, in terms of really wanting people to finally take for granted administration and back-end tasks that right now have been at the forefront just due to the simple technical challenges they've posed. Okay, so now let's go into a demonstration where we'll talk about a few different scenarios, including reporting, search and discovery, security matrix management, etc., etc. So the first thing I'm going to do, okay, if we kind of step back for a moment and look at what MetaMiner really is a metadata database. And that metadata database, of course, has a number of standard reports that is provided with the product that allows us to do very basic and advanced metadata reporting on my platform statistics. So, for example, if we look at our folder security matrix, this information is retrieving data from security tables that we've populated and persisted to the MetaMiner database once we started running that engine. Here on the left you can see input controls that allow us to restrict different criteria of our report, so we can look at all of the users and groups that have no access across different folders in my environment. The scheduling statistics report gives us insight into the different scheduling behavior of my reports across multiple environments. Here we're looking at 2 environments, and looking at this first page, we can see that generally speaking, our scheduling activities seem to be going quite well, where we have just a minimal number of failures, in this case 3 here and 2 here, but overall a high degree of success. The monthly schedule volume also tells us that generally speaking, schedules have been basically normalized across each day of the month, although we do have a few days there where there's a dip, and in fact there's actually a gap between 12 and 18 where it looks like there was roughly a 1-week period where scheduling activity was at a standstill. The Instances by Folder tab gives us even more insights around scheduling. Here we're taking a look at all the number of instances at the folder level aggregated. So if you have any outliers, or in fact if you have a highly self-service community where many people are doing ad hoc reporting and scheduling, you might see, if you don't have any limits placed, where there's an explosion of number of instances on this column, where the number of instances is more than what you would typically expect. The duration in seconds gives us additional information around how long, on average, reports are taking in general for that folder. And the size in MB tells us a rolled up total of all the instances in the space that they consume for that folder. Finally, instance details drills into the specifics of just what happens with these instances and events where they fail. And as you can see, we've got a very clear printout of all the error messages and the failure types as we scroll up and down this report. Now, going a little bit into impact analysis, we can also move away just from simple scheduling instance analysis and take a deeper look at what happens when we modify a particular universe name or document name, or universe name or result object, and see the downstream impact of the documents that affects. So here, if we look at result object name and we see margin, year, and sales revenue, we can actually put a filter and specifically look at all of the objects or all of the documents that are affected or use the sales revenue object. So we can tell our data warehousing team that, okay, well, hold on. Before you modify the sales revenue universe object, beware that we've got 1, 2, 3, 4, 5, 6 reports that will be impacted by changing this universe object. Sessions analysis gives us insight into the sessions of the system, or user activity. If we take a look at this graph, we can very easily see by hour of the day just how many users are logging onto my system concurrently. So it looks like in the last 6 months that hour 22 shows us that we have the highest number of sessions, which is pretty much between 2 and 3. You know, demo environment, not too many. But again, this report is a very great way to determine your peak concurrency, especially useful in licensing scenarios. The session time by group hour is also very interesting. This tells us at the group level the total number of hours spent on the system by hour of the day. So this may help an administrator determine if there's any downtime that needs to take place on the system and when they can make that downtime occur, which would be essentially the least busiest time of the day. Perhaps the very tail end of the day might suit that administrator looking at this particular report. The metadata documentation capabilities of MetaMiner are fairly vast. Here we have two examples of where we're documenting all the contents of a UNV as well as contents of UNX. So many data warehousing team members often ask, what are all the select statements or columns or tables used within this universe? Because we're about to change something. Or your compliance team simply may want to have a well-documented metadata catalog of all of your universe and UNXs. So here we have the opportunity to finally do that through MetaMiner. We also have utilization reports that tell us just how much the system is being used over various periods of time. User last logon activity is quite interesting. This gives us information about how recently users have logged in and those users who just haven't logged on. So this report tells us that over the last 12 months we basically have 2 users who have logged on as recently as in the last month, specifically 7 days ago. But actually, the interesting thing here is that beyond those 2 users, no one's logged onto the system. So for those installations that have named user policies, you may wish to disable or remove those users who have not logged on ever or have logged on more than 12 months ago to make way for new users to come and enjoy the benefits of your BI installation. The document usage last 12 months is also quite interesting. This report gives us insight into the documents utilized on the last 12 months. So if you're migrating or moving from XI3 to BI4, for instance, it may be interesting to know what documents you need to migrate and which ones you just don't. So having that ability allows you to now carve out only the useful parts of your XI3 environment, as we know that if you have tens of thousands of documents, not all of them may necessarily be relevant, at this current time. And by doing that, you're reducing the footprint of your migration, which ultimately reduces the time it takes to migrate and the cost associated with that. So those were just a few examples about how MetaMiner helps reveal very interesting statistics of the system by allowing us to query directly against that MetaMiner database that's being populated in near real time by the MetaMiner engine. One final report I'd like to share with you is the MetaMiner server overview report. And this report gives us a very nice comprehensive view of all of the metrics and configurations by server type across all nodes of my cluster across all environments. So in theory, we can simply click on Webby Server, and when we do that, okay, if we had anything here, we can see all of those statistics right in front of us. Okay, and the same thing here over for configuration. So we can see all the different configurations. So if I wanted to look at auditing, whether auditing was enabled across my systems, again, we can say configuration setting name. And here we can see that auditing has actually been disabled in a few places. So that could be a concern. People might be wondering why they're not capturing information in the audits. And of course, the alternative of having to do this would be right-clicking through a number of different screens in the CMC, which of course can be challenging, especially in larger environments. But of course, when we're looking at reports, reporting isn't necessarily enough, especially when we want to close the loop, right? For example, we have a lot of scheduled instances that are failing, but once those scheduled instances are failing, or whether they're complete, how can we delete them in bulk, or maybe save them or archive them to disk if we're running out of space? So the reporting, of course, is a static representation of this information, and that's where the MetaMiner UI helps us go beyond just reports and allow us to actionize much of the information in our repositories. So what we're doing here is we're loading up with the MetaMiner client a MetaMiner server that's connected to two environments, XI3 and BI4. CMS Explorer is what we call the home page of the MetaMiner UI. It's where we can find all the objects and universes and things around the documents and folders of my entire landscape. Environment 1, 2, 3, 4, 5, all represented right here. To the far right, you see number of documents. Number of documents is exactly that. It's a rolled up number that provides an interesting analytic of the total count of information at the highest level. So this CMS, or this environment, only has 1,100 reports, whereas this has 8,000. Now a common workflow might be, let's go and take a look at all the failed instances, okay, in my entire organization. So all we really need to do is go and click on failure. When I click on failure, you can see that we've what we call, we can now highlight all of those failures again in tree format. So it makes it much more intuitive and easy to analyze this information. And of course now what we can do is I can type in a search string. So here you see 5,000 total failed instances, and I'm looking for some very specific information. So I type in pipeline, and you can see that we've got 2 failures under pipeline out of the original 5,000 items here. Okay. Now, one other thing we can of course do is we can look at a very specific window of information. So now let's say I want to look at just 2 days worth of failed instances that I know were due to some type of patch or upgrade or testing that we did, and we just don't need them in the system. So let's go ahead and let's click on failures created in May 18th to May 20th. And now you can see that we've got how many? 216 that fit that criteria. Okay. So now I can use my smart selector, select folder contents only, deselect the actual parent instance, and go ahead and click delete. And this is just a typical example of how we can do this type of write back in MetaMiner. The next workflow we're going to demonstrate is how we can take this captured instance, or the next workflow we're going to take you through is how we can actually archive information in MetaMiner and persist it to disk just by using our basic selection criteria system. So what we'll do here is we're going to type efashion webby instance. And when we do that, you can see that we selected a number of reports from both environments. In environment BI41, we've got 10 reports, and in here we have 31. Now that we've selected the objects, we can see that we've got 31 in the XI3 environment and 10 in BI4. We're going to focus in the BI4 environment, in the XI3 environment, and we're only going to focus on our completed instances. Now that we have the completed instances that we were looking for, we can simply go ahead and arbitrarily select any number of them, and then use these as candidates for backup. So we're going to call these backup efashion icons.zip. Now that we've done that, you can see that MetaMiner produces a zip file that is basically a first-class folder structure that had exactly what we had in our CMS. So we have public folders, efashion, the root parent report, and then all of its instances correctly persisted to disk. So here's the parent report. And then these are, of course, all the instances of that report that are now here. So that's one example of object management within MetaMiner. Now, I may have had another use case where we want to actually promote this content into my higher level environment, or in my same environment, or another environment in the same version. So here, of course, we're starting in Excite 3, and MetaMiner is actually connected to several different places. So we can now go ahead and take these same reports that if we, for example, didn't want to archive them to disk, we can just simply promote them as you might in Promotion Manager by right-clicking, clicking Export, and then clicking OK. It allows us to perform these actions after we do this highly selective, we perform this narrowing of the content and filtering of the lists. So here we're looking at 11 selected documents, but we really have 11,000 in total. Okay. Beyond that, there are several other interesting capabilities just within the MetaMiner CMS Explorer. One is looking at impact analysis at the universe level. So I can click here, and you can see that, for example, when we click on Auditing UNX, we can see that all of the reports being selected within 38 here and 38 there. Now, another common use case is wanting to understand what the security matrix of a system looks like. So here we can click on Excite 3, and then once we do that, going to Public Folders, and if we can filter out all these other reports by clicking Show Folders Only. And now what I've done is I've effectively created an environment where we're just looking at a series of folders. And at this point, we can just arbitrarily select any number of folders, right-click, and then go to Explore Security. Once I do that, as I scroll through, you can see my complete security matrix, and the security matrix allows us to then not only view and export that same data, but also gives me the capability to right-click and modify any number of cells, as I do here, and at this point go ahead and modify the selections so that we've now arbitrarily selected full control for those folders for these users and groups. And conversely, we can just clear the security settings and reset them to where they were before. We can also add any number of principals on demand within the screen. So for example, if we had 2 contractors coming on board, and we need to specifically give them full control to just a few folders, we can click on what those folders are here, here, and here. I can go to Add Principals, and then I can choose that user here. Of course, our widget allows us to do search and discovery through a number of different places, and we're going to give them full control. Okay, so now you can see here that this user, which also the tooltip tells me all the groups that they actually belong to, is now given full control for those folders I selected. The Users tab, again, just like the CMS Explorer tab, gives us a fully treeified representation of the CMS in just one fell swoop. So here, if you look at the accounts on the right, we've got hundreds of users in any of these given groups, and MetaMiner, of course, has the capability in superscale environments to not just represent hundreds of objects, but hundreds of thousands of objects, even up to a few million. One interesting workflow here is being able to understand who's logged onto the system in the last 6 months, or who hasn't logged into the system in the last 6 months. So here we can just click on last logon time was either sometime from the beginning of time up to maybe March 1st. And when we do that, you can see here that last logon time is in fact either empty or many, many months ago. Okay, now if we actually select an actual date, here we can see that these are the actual users who haven't logged in for some time. Not only that, but we can actually go ahead at this stage and we can save these users back to a buyer backup and then delete them from the system, or we can just delete them right here and right now. The Servers tab allows us to understand the different server metrics across our environments. So here we're going to go on server type, Webby server, and very quickly it allows us to understand all the current metrics and configuration values for any of the given servers for that particular server type. The Visual Diff tab allows us to compare metadata not only across folders and objects, but objects themselves, and even going deeper than that, but the data within a report. For example, supposing we're in a migration scenario or we're upgrading a patch, going from 4.1 SP6 to SP7. I may want to take my pre-migrated environment and then take my new sandbox SP7 environment and just take a look and have an understanding of if both of those environments have been set up and mirror one another. So the first thing I'll do is I'll drag public folders on the left target and then public folders on the right target. Here we can see that the data in one system is not similar to the data in another system. And in order to look at those differences, we can see that, well, things that are in red have been added on the left but don't exist on the right. Things in green exist in the environment on the right but not on the left. But the things in yellow exist in both environments but have been modified to some degree. Now, if we look at test reports, based on CUID and last modified date in the presence of instances, which are the three criteria we use to do comparisons, these nodes are exactly the same, right? And now if we relax our restrictions, we can see here that we actually do have several folders that have been assessed to be the same when we don't compare CUID, last modified date, and the presence of instances. Now going a bit deeper, let's take a look and compare universe files. So here what we'll do is we'll take two versions of an eFashion universe. And when we do that, you can see here that we've got 6 changes across our system. And each bundle of changes is referred to as a change. So we've got 1, 2, through 6. And now if I hide all the properties, you can see here more clearly where those changes occur. So it looks like someone actually added a fairly large class under time period on the right here that's missing over here. And they've taken some of our filters like this year, last year, holiday period, etc., and they've moved them directly under the time period class, whereas over here they were tucked away under a few subclasses. And finally, we can actually compare data values within Web Intelligence reports. So for example, I may want to look at the content in this report versus the content on this report. And this is particularly useful when we're trying to understand changes in a calculation engine. So here you can see that on the report on the right, someone's modified the title, so we see a change in yellow, and they've added a count on this column where it says 3. If you want to compare security, that's also possible using the security diff module. And the security diff module, again, is a fairly straightforward module where we can go here and basically just take any 2 arbitrary folders from the same or different environments and then take a look at how security has been set up for them. Now, in this case, there may be a scenario where I actually want to add principals to the bottom folder. So now I can go ahead and say, well, these 2 people actually really ought to have full control. And now, in real time, MetaMiner's gone ahead and made the change directly to the CMS via the UI. Impact Analysis database allows me to understand all of the downstream impacts when we modify reports or universes and want to understand all the documents that will be affected by those changes. MetaMiner creates a SQL tree based on the decompilation of all of the SQL components, whether they're from freehand SQL and web intelligence reports, or data providers written off of Oracle, Teradata, PostgreSQL, etc. And after decompiling that SQL, it recompiles it into, as I mentioned, a database object tree that gives us all the tables and columns constituting those reports' data providers. So in this case, let's go ahead and type in revenue. And again, you can see how Instant Search immediately filters all those results and allows me to simply select the columns that I'm interested in, now you see the result of all the columns using sales revenue. And again, I can expand this and use our quick filter and look for very specific reports now. Okay? And all of the widgets that you see where we have any type of result or output, of course, can be exported to Excel. Impact Analysis Universe follows the same paradigm, where we can either drill down into the different universes and columns we have here, and then maybe select some of those classes, and now finally those objects as well. And now what we'll do is try to see if there's any documents that are making use of these universe objects. Again, helping us determine or get back to the data warehousing team if they do plan on modifying any particular object to let them know what object or any type of item in the data layer, and then knowing what objects are in use by them. So now we can see all of those reports using these different measures found in the eFashion3 universe in the Sandbox XI3 environment. And again, we can export these right back to Excel. Talk about is MetaQuery. And MetaQuery is a SQL workbench that allows us to drill into all the very specific low-level content of our system. One example is trying to assess the changes in the Web Intelligence calculation engine by first verifying what variables are used in our own Web Intelligence landscape that may be using functions or formulas that will be impacted by an upcoming Webby calculation engine change. Using the word count and distinct will be affected. So the first concern that we have is, what are the reports in our environment using these very specific items in their objects or variables? So we'll go ahead and type in a very simple ANSI 92 compliant SQL script that will search all of our variables for this word count. When I run this, you can see here under formulas that we've got a number of different occurrences. Now I'm going to type in distinct. D-I-S-T-I-N-C-T. And when I type distinct, we can see that there's a number of objects using count and distinct. And at this stage, what I can do is click Show as Tree. When I do Show as Tree, you can see that I've got 32 objects, or 32 reports in total, 30 in my auditor folder, and 2 in Infolytic. And at this stage, I can go ahead and save these reports out to disk or make a buyer backup and share it with a user. Alerting is a fairly interesting capability that allows us to create alerts in 3 different areas of our system. The first being alerting on server availability. The second is an alert on Tomcat or any type of web response time. And the third is an arbitrary alert that's called SQL alerts that allow us to be notified of any arbitrary event in our environment based on changes in the MetaMiner database data that we capture. Any of these alerts can of course be emailed to email or SMS within our organization or sent externally, where you would configure the SMTP internal company email server in the MetaMiner preferences prior to creating alerts. Let's go take a look at what that looks like. So in this alert, we're looking at CPU usage. Now the CPU usage alert says, send us an alert every so number of minutes for metrics that have the word CPU usage in it. So what we can do is we can first go to MetaQuery and we can run this alert or run this analysis, and we can see here that right now we've got some systems that have CPU of greater than 7%. So the actual alert itself can be modified where we do something like and metric value greater than 0.15. So when CPU usage goes higher than 15%, what we'll do is we'll send an alert to myself and other people in the organization, and then we can even send an SMS so that those who want to be notified of the alert via mobile phone can be notified. Another type of alert is a server-based alert. And in this alert, we're going to say CMS is down. And we're going to do it on a production BI4 system. And we're going to choose BI4 CMS. Okay? And for this alert, we're going to send it at support@infolytic.com and also send an emergency message. And this alert will check every 1 minute. So each minute we're going to do a ping on the CMS to see its availability. Another type of alert that's interesting is users listing report that tells us all the users that have logged on to the system at any given point in time. And of course, we can make all of these alerts sensitive to the time that the alert last was evaluated by using tokens. Tokens allow the alert to be triggered based on a point of comparison, a historical point of comparison. So we can either have the alert fired based on the last time the alert was fired, or the last time the alert was processed. So as you can see, MetaMiner has a great many number of capabilities that allow us to perform very deep and very specific platform analysis. And once we understand more of how these different workflows or the workflows in our environment that need to be accomplished, we can very quickly then weave that workflow into the way MetaMiner works to perform the analysis, determine the action we want to take, and then take that action and then understand by rescanning the metadata that happens in near real time of how that change was implemented. And don't forget, all the MetaMiner information that you see here that's coming back is managed through our MetaMiner engine, which of course is and of course don't forget that all the is managed through our MetaMiner engine that is updating all this metadata in near real time. And here you can see that all of the object counts are matched up, which means that MetaMiner has fully synchronized its environment as we had expected it to. Thank you for joining. If you have any questions, please feel free to contact us at info@infolytic.com.